Every atom is like a mini universe. But deep inside it, three tiny heroes work together to decide everything about what that atom is, how stable it is, and how it behaves. Today, we're zooming in inside the atom to meet three of the tiniest but powerful particles in the universe: the proton, the neutron, and the electron. Last time, we learned that every atom has a dense core called the nucleus, and surrounding it, like layers of an onion, are shells where electrons move around. But today, we're taking our zoom lens even closer to uncover the tiny secrets hidden inside. First up, the leader of the pack, the proton. Let's start with its symbol. Protons are represented as P+ because they carry a positive charge. That little plus sign is important. They have a positive 1 charge, meaning they contribute a positive electrical force inside the atom. Before we talk about the mass of these tiny particles, let's first understand the unit scientists used. It's called the atomic mass unit, or AMU for short. 1 AMU is about 1.67 times 10 to the negative 27 kilograms. That's incredibly tiny. Even if you had 1,000,000 trillion protons, they would still weigh less than a grain of sand. Using AMU makes it easier to talk about mass without getting lost in long numbers full of zeros. Protons are relatively heavy for a subatomic particle, around 1 atomic mass unit, or about 1.6726 times 10 to the negative 27 kilograms. And where we can find protons? Protons sit right at the center of the atom, in the nucleus, where they help define the identity of the element. Protons are like the identity card of an atom. They tell us exactly what element it is. Think of protons like your ID card. They decide who you are. If you have 1 proton, you're hydrogen. 3 protons, you're lithium. 6, you're carbon. If you have 118 protons, you are the rare and heavy oganesson. Change the number of protons and change the element completely. Protons are what gives an atom its true identity. So protons give an atom its identity, but there's someone else working quietly beside them. Someone just as important, but much more neutral. Let's meet the neutron. Neutrons are the calm, neutral members of the atomic family. Neutrons are represented by the symbol N0, and that little zero, it tells something very important. They have no charge, they're completely neutral, which is actually where their name comes from, neutron. Neutrons have about the same mass as protons, roughly 1 AMU, or about 1.6749 times 10 to the negative 27 kilograms. Just slightly heavier than a proton. Neutrons also live in the nucleus right alongside protons. Neutrons may not have a charge, but don't let that fool you. Their real power lies in keeping the atom's core from falling apart. Let's see how they help maintain stability inside the nucleus. Inside an atom's nucleus, protons are packed closely together. But since they all have positive charges, they tend to repel each other. If nothing stopped this repulsion, the nucleus would become unstable and eventually break apart. This is where neutrons become important. Neutrons have no charge, but they help by reducing the repulsion between protons. They act like a stabilizer, or think of them as atomic glue, holding the nucleus together and keeping the atom stable. Neutrons help keep the atom stable, but having too many or too few can cause problems. For example, carbon-12 has 6 protons and 6 neutrons. It's stable. Carbon-14 also has 6 protons but 8 neutrons. It's still carbon, but the extra neutrons make it unstable. That's why carbon-14 is radioactive. Neutrons are like glue, but without the right amount, the nucleus can fall apart. So yes, neutrons help hold the atom together, but they aren't the ones making atoms interact. For that, we need something smaller, something faster, something charged with energy. It's time to meet the electron. The electron, written as E-, that tiny minus sign, it means big things in science. Electrons carry a -1 charge. That's the exact opposite of a proton. This negative charge is super important for electricity and chemical bonding. Electrons are extremely light, about 1/1836 the mass of a proton. To put that in perspective, imagine a balanced scale. On one side, just one proton. On the other, it would take about 1,836 electrons to balance the scale. That's how tiny electrons are in terms of mass, almost weightless on the atomic scale. And unlike protons and neutrons, electrons aren't in the nucleus. They zoom around it in areas called shells or energy levels. Electrons are in charge literally of all chemical reactions. They decide how atoms interact, bond, and form everything from water molecules to living cells. Now, electrons may be tiny, but their role? Massive. Let's zoom in how electrons drive chemical reactivity. Electrons, especially the ones in the outermost shell, called valence electrons, decide how an atom behaves in a chemical reaction. Atoms become more stable by gaining, losing, or sharing these electrons. Think of electrons like social connections. How atoms interact depends on how many friends they have or want. So yes, electrons bring the excitement in chemistry. They're the ones forming bonds, breaking them, and starting all the action. But here's the thing. Electrons don't work alone. To truly understand how an atom behaves, you have to meet all three players. Because every atom's story is a mix of identity, stability, and reactivity. Protons give the atom its identity. They say, "This is who I am." Neutrons add stability, keeping the nucleus from falling apart. And electrons drive reactivity, deciding who to bond with and when. Together, these three tiny heroes are the reason everything exists, from the smallest grain of sand to the beating heart of a star. And that's a wrap. This is Learning with G. Stay curious, stay inspired, and I'll see you in the next lesson. Thank you so much for watching.